need to know about what is the optimum number of rain gauges required in a rain gauge network. Okay, rain gauge network consists of number of rain gauge station, and these rain gauge stations should be optimum. And this is the formula to calculate optimum number of rain gauges. N is equal to Cv upon P bracket square. Okay, so with help of this formula, we can find out optimum number of rain gauges. Optimum number of rain gauges are necessary in order to calculate the accurate estimate of average precipitation. During practical, we have seen various methods for calculation of average precipitation. So in this formula, Cv is coefficient of variation of rainfall values at existing M stations, and this is expressed in percentage, whereas P is the allowable degree of error in calculation of average precipitation, and that is also expressed in percentage. And this Cv is calculated with this formula, and we have solved one problem on that. Okay, so we have solved this problem. Okay, in this problem, there is a rain gauge network for a catchment area, and there are 5 rain gauge stations available. And for 5 rain gauge stations, the daily annual rainfall record is available. So that is given here. And we have to find out optimum number of rain gauges for 6% permissible error. So we have solved this problem in previous lecture. So this is the last point in the previous lecture. We have worked out value of n as 7, and we know that here number of existing rain gauge stations which are indicated by small n are 5. So here additional number of rain gauge stations are 2. So based on the area, these rain gauge stations are uniformly distributed. Okay, that is one factor. What is other factor? Other factor is based on the topography. The location is decided. So this we have learned in previous lecture, and we have also learned about how to calculate the missing precipitation data. So to estimate missing precipitation data, there are 3 methods: arithmetic mean method, normal ratio method, and inverse distance method, which is also known as US weather method. Okay, so before that we have discussed a few terms. First is daily rainfall at a rain gauge station, second is annual rainfall at a rain gauge station, and third is normal annual rainfall at a rain gauge station. So normal annual rainfall is the average of annual rainfall values for a period of 35 years for a rain gauge station. Then you know what is arithmetic mean method. With help of this method, we can find out the missing precipitation data. Okay, this second one is normal ratio method. In normal ratio method, precipitation at existing stations, they are weighted. विश्वजित मगर म्यूट करा तुम्ही स्वतःला. Roll number, okay. So this is normal ratio method. In normal ratio method, the precipitation, daily precipitation data is weighted with normal ratio nx upon n1, where nx is normal annual rainfall of missing station and n1 is the normal annual rainfall of index station 1. So similarly, it is P2 into nx upon n2, and it is up to Pn into Nx upon Nn. So when the normal annual precipitation of index station differs more than 10% of missing station, in that case this normal ratio method is used. We have solved this problem. The next method is inverse distance method or US weather service method. So this method is the most accurate method to estimate the missing data, and formula to calculate our missing precipitation data Px is summation of Pi into Wi upon summation of Wi, where Wi is the weightage for a rain gauge station, and rainfall value at a rain gauge station is multiplied with this weightage, that is Pi into Wi, and this Wi is what it is calculated as the inverse of square of the distance between the missing data station and index station, and this can be worked out with reference to the coordinates of that particular rain gauge station. Coordinates of the rain gauge stations are worked out with reference to the coordinates of missing data station. So we have seen that X is missing data station, for which it is coordinates are 0, 0. It is considered as origin, and with respect to that, the coordinates of station A, B, C, and D, they can be easily worked out, and from these coordinates it is possible to calculate dA, dB, dC, dd, and hence it is possible to calculate WA, WB, WC, and WD, and from that, using this formula, then it is possible to work out Px. Again, we have solved one problem on this during our practicals. Just a minute. Okay. Okay, then we have learned how to calculate the average precipitation value. There are three methods to calculate average precipitation value. In that, first is arithmetic average method, in which all the values of the rain gauge stations in the area, they are simply added, and then they are divided by number of rain gauge stations. So simply arithmetic average is taken for the rainfall values available in the rain gauge network. So we have solved one small problem on that, and this method was rough, and that's why some precise methods are invented, and this is the second method, Thiesen's polygon method. So Thiesen's polygon method consists of construction of Thiesen's network. For that, we have to join the rain gauge stations by straight lines, and then for the straight lines we have to draw the perpendicular bisectors, and through these perpendicular bisectors and boundary of the catchment area, the entire area is divided into number of areas, and this construction is known as Thiesen's polygon or Thiesen's network. Now in this method, the precipitation value at any rain gauge station is weighted with the ratio of area. Okay, it is weighted with the ratio of the area. For station A, area is A1, precipitation value is P1. So it is A1 in P1 into A1 upon summation A. So A1 upon summation A is what? It is the weightage given to that particular rainfall value. So considering this formula is developed for P average. P average is equal to summation of A into P upon summation A, where A is area of each Thiesen's polygon. Summation A is total area, and P is the rainfall value at a particular rain gauge station. Also, we have solved problem on this calculation of average precipitation by Thiesen's polygon. Okay, this Thiesen's polygon is having certain drawbacks. The main drawback is it does not consider the topography of the area, and topography of the area highly affects the precipitation values, rainfall values. So one more precise method is invented, and that method is more precise as compared to previous two methods, and this method is known as isoheightal method. In isoheightal method, isoheights or isoheightal maps are created. For a storm, isoheightal map is created. Isoheightal map is a map which consists of isoheightal lines, and isoheightal lines are the line joining points of equal precipitation. Now, if this map is available, in that case, with help of this formula, that is summation of A into bracket P1 plus P2 upon 2 upon summation A, we can find out P average. So this isoheightal method considers the topographical effect of the area due to which the rainfall is either less or more. Based on that, again, we have solved problems on this, and these are some problems. Okay, we have solved one problem, and this is one more problem given in the book. Now, after this, we will discuss about the term mass curve of a rainfall. This mass curve of a rainfall is output of recording type of rain gauges. We have learned about recording type of rain gauges. We know that in recording type of rain gauges, some mechanism is there to record the rainfall. And with help of this mechanism, rainfall is recorded. And in this mechanism, there is a graph paper. And on that graph, the marks are there on the graph paper, and it is with reference to the time, and it is with reference to the rainfall value at that rain gauge station. Now on that graph, such a curve gets plotted with respect to time. So everybody carefully observe this graph, what this graph shows. So this graph shows cumulative rainfall values with respect to time. On x-axis, there is a marking for time interval. So in this figure, you can see this time interval is 4 hours. After every 4 hours, the rainfall is recorded. Which rainfall? Cumulative rainfall. What do you understood from cumulative rainfall? Suppose from 0 to 4 hours, cumulative rainfall is 2 centimeters. So cumulative is total. So during these 4 hours, total rainfall is 2 centimeters. Then from 4 to 8 hours, suppose rainfall is again 2 centimeters. So it is cumulative rainfall up to 8 hours is 4 centimeters. Just we have to go on adding the total rainfall values from the starting time. So that value is a cumulative rainfall value. Now on y-axis, cumulative rainfall values are plotted. On x-axis, time is plotted. So see this graph A, B, C, D, E, F. See how many points are there. Just a minute. Okay, so if we observe this graph carefully, then we came to know that from the point A to B, there is a session of rainfall. Okay, the rainfall takes place from point A to B. Okay, what is the duration of rainfall? Duration of rainfall is 12 hours. Okay, so this is the first storm. This is the first storm. And how much? This is a storm means what? It is a session of rainfall. So in this session of rainfall, how much total rainfall takes place? See, for point B on y-axis, this value is 4 centimeter. So there is a first rainfall session, there is a first storm, okay, which yields 4 centimeter of total rainfall. So from this graph, we can find out what is the total rainfall. Okay, so storm wise, we can find out what is total rainfall. Now see, what is the total duration? Total duration is how much it is? 0 to 24. This is 1 day and this is 1 more day. Okay, so we can find out what is the total rainfall for a day from 0 to 24 hours. Not only we can find out the total rainfall, but also we can find out what is the intensity of rainfall. Now you observe this figure and you consider portion C to D. Okay, so C to D, there is a second spell of rainfall from C to D. That is from 16 hours to next day 4 hours. 16 hours to 4 hours. There is a second session of rainfall. And again from C to D, we can find out this vertical intercept. That is the cumulative rainfall, and this is obtained as 3.6. So for second session of rainfall, total rainfall value is 3.6. Along with this total value, we can find out what is the intensity of rainfall. Okay, intensity of rainfall I is given as delta P upon T. Delta P is what? Delta P is total rainfall. So it is 3.6 divided by delta T. Delta T is what? It is the time interval in which this rainfall takes place. So it is from 16 hours to 4 hours. So if we divide the total precipitation divided by total time required for the rainfall, then we get intensity of rainfall, which is expressed in centimeter per hour. So from this mass curve of rainfall, not only we get total rainfall, but also we get the total rainfall for various rainfall sessions, for various storms. Also we can identify the dry spells. Dry spell means what? There is no rainfall. So in this figure, from point B to C, we can see that there is a horizontal line. So what this horizontal line indicates? This line indicates that there is no addition of water. Okay, so there is no rainfall from point B to C. Similarly, there is no rainfall from point D to E. Okay, so there are two dry spells. First dry spell is for 2 hours, 4 hours, that is from 12 to 16 hours. Second dry spell is for 4 hours. It is around 4 to 8 hours. Okay, and after that there is a third session of rainfall. So third session of rainfall is having total rainfall value of 2.6 centimeter. So this is how this mass curve of rainfall is useful in getting information about the spells, rainfall spells and dry spells. Okay, also we get information of the total rainfall value, intensity at any point. Also, we came to know dry spell duration. Okay, also we can find out what is the total precipitation for a particular storm. Okay, so from in these 2 days, if we see, there are 3 sessions of rainfall and there are 2 dry spells. So this is the use of mass curve of rainfall, which is output from some recording type of rain gauges. So is it clear to all what is mass curve of rainfall? It is a curve plotted between cumulative rainfall and time. From this curve, we get information of all these points. Now on the screen, there is one more graph is shown. And that graph is known as hyetograph. Now what is hyetograph? Hyetograph is a graph plotted between intensity of rainfall and time. So this is hyetograph prepared for one storm, and the duration of storm is 12 hours. And in this entire duration, if the time interval chosen is 2 hours, then for each 2 hours, the rainfall intensity is different. Now, in this graph, this rainfall intensity is on y-axis and time is on x-axis. Rainfall intensity is given in centimeter per hour. Now consider first 2 hours spell in which the rainfall intensity is 0.4 centimeter per hour. So what is the total rainfall in 2 hours?
आपण ज्याला कॉल केला आहे तो आता कुणाशी बोलत आहे.
तेजस दराडे म्यूट करा. Yes, answer this question. What is my question? If rainfall intensity for first 2 hours is 0.4 centimeter per hour, then what is total rainfall for 2 hours? सांगा बरं. See, what is the formula for rainfall intensity? Rainfall intensity I is equal to what? Total precipitation P upon time. Total precipitation P upon time T. Okay, this is rainfall intensity. So here it is expressed in centimeter per hour. So if we have to calculate total precipitation, then what we have to do, we have to multiply this rainfall intensity with time. This is the formula. So if this is the formula, then tell me what is the total rainfall in first 2 hours? Yes, who will answer this question?
Sir, 0.8.
0.8. Okay. So 0.8 is the correct answer. See, intensity is 0.4 centimeter per hour. Okay, and time is 2 hours. So 0.4 into 2, it is 0.8 centimeter. Okay, so this gets cancelled. This is how, if intensity is given, we can find out precipitation. And if precipitation and time is known, we can find out intensity. We can go reverse also. Now you tell me, if total precipitation P is 50 mm and total duration T is suppose 4 hours, then tell me what will be the intensity? What will be the intensity?
Sir, 12.5.
Right, it is 50 divided by 4 centimeter per hour. Is it clear? So that is the relation between intensity of the precipitation and total value of precipitation. So what is hyetograph? Hyetograph is a graph plotted between rainfall intensities versus time. What is mass rainfall curve? Mass rainfall curve is a graph plotted between cumulative rainfall versus time, and it is output of recording type of rain gauges. Okay, now we are going to learn about one more technique that is known as double mass curve technique. So what is double mass curve technique? The purpose of double mass curve technique is to check the consistency of rainfall records. Okay, its purpose is to check consistency of rainfall records. And what data is required to prepare this graph, which is known as a double mass curve? To prepare a double mass curve, we need information of accumulated annual rainfall values at station X. So X station is a test station for which we have to check consistency. Now to check consistency means what? Means to find out whether the recorded data is correct or not. Sometimes the recorded data may be incorrect. Okay, so that may be incorrect due to various reasons, such as shift in the observation practice. Means what? Shift in observation practice means, suppose there is some attendant who is taking these daily rainfall values, and suppose his duty changed from that place and a new person came. So again he is taking the readings. Okay, so that is the shift in observation pattern. Then there may be a dents in the collector rim. We know that there is a collector rim. Okay, it is circular in cross section and it is having a funnel. So that rim, in that rim, the dents may be developed because every day that has to be pulled out from the place. Okay, and that water receiver bottle has removed and then rainfall is measured. So during this daily use, so dents may be developed in that collector rim and which may record the incorrect data. Okay, so one more reason is shift in atmospheric parameters. Okay, we know that due to this globalization, the temperature is increasing, and due to that there is a change in the rainfall pattern in the area. So due to such reasons, the recorded data will be with some recorded data is with some error. So how we came to know whether such errors are there or not? For that, this is the technique which is known as double mask curve technique. Okay, so now I think clear to you what is the use of double mask curve technique to check the consistency of rainfall records. And this double mask curve is plotted with reference to two data. One is the accumulated annual rainfall at station X. Station X is one station for which we are going to check its consistency. Okay, so station X is a test station for which we are going to check the consistency of rainfall records. So at that station, we have the annual rainfall values. Okay, from certain period for certain duration, accumulated annual rainfall values are worked out. Suppose for first year it is 10 centimeter, then for second year it is suppose 20 centimeter. So cumulative annual rainfall at the end of second year is 30 centimeter. Okay, likewise, accumulated annual rainfall values are worked out with respect to time for that test station. Okay, now let us say this station name as station X. Then we also need the accumulated average of annual rainfall at 10 index stations. As we have considered accumulated annual rainfall at test station, that is X station. Similarly, we have to consider 10 surrounding stations. We know that surrounding stations are known as index stations. So for these 10 stations, again we need the accumulated average of annual rainfall values. So if we have these two datas, then this curve can be plotted, which is known as a double mask curve. So what is double mask curve? Double mask curve is a graph plotted between accumulated annual rainfall at station X and accumulated average of annual rainfall at 10 index stations. Now, when we came to know whether the recorded data is consistent or not, if the data is consistent, in that case, the graph is a straight line. And if the data is not consistent, in that case, there will be a break in the graph. So if there is a break in the graph, then the data after the break is not consistent and it needs to be corrected. Your assignment number 2 is based on double mask curve technique. Now on the screen, this is the double mask curve plotted. So see what is plotted on x-axis. On x-axis, the accumulated annual values of 10 stations are plotted. And on y-axis, accumulated annual values at station X, they are plotted. And these values are plotted for number of years. Now here, from 1985, from 1970 to 1985, these values are plotted. Okay, and we see that there is a break in the graph. Okay, there is not a single slope to the graph. We have to calculate the slope for line AB separately and line BC separately. So calculate the slope of the line AB and line BC. So slope of the line AB is suppose 1:A and slope of line BC is suppose 1:B. Then from these two slope values, we can find out the corrected values. Okay, so corrected precipitation values after the break, they are calculated as Pxc is equal to Px into A upon B, where Px is what? It is a precipitation value at that station. Okay, Px is a precipitation value, recorded precipitation at station X, and it is at time period T. Whereas Pxc is corrected precipitation at the test station X at any time period. So this, to calculate the corrected precipitation value at test station X after the break point, we have to multiply this Px with the slope ratio. Okay, slope ratio is A upon B. So 1:A is the slope of line AB when the data is consistent, and 1:B is slope of line BC when data is not consistent. So if we multiply the precipitation value with this ratio, then we get the corrected precipitation values. So this is double mass curve technique. So based on that, there are the problems. Okay, these problems will not be asked in the theory examinations conducted by Shivaji University, but this is for your term work, that is a part of assignment number 2. So on coming Sunday, we will solve this problem for double mass curve technique, and we will find out the corrected rainfall data with reference to this graph and the formula. Okay, so now this is a somewhat different thing I want to show you here. So that is the rainfall record data. Okay, so this rainfall record data is available on maharain.government.com. It is also available on mahaagri.government.com.in. Okay, both are the government sites where you can get the information of rainfall. Okay, information of rainfall of a particular date. Also, we get information of rainfall in all parts of Maharashtra. Okay, and this information is collected on the basis of circle. Okay, in a taluka there are so many circles, and for all circles the rainfall data is worked out. So this is a screenshot of that website. Now everybody observe that table, circle wise rainfall for the Kolhapur district. Okay, and see the values of June and July and total values from June onwards. Now consider the first information. So it is regarding to Hatkanangle circle. Okay, for Hatkanangle circle in the month of June, what is the actual rainfall? Actual rainfall value is 1333.2. Okay, this is the actual rainfall value. Whereas what is the normal rainfall value? Normal rainfall value is 117.5. Okay, so what is the percentage more than the normal? So percentage is 113.4. Okay, so this year, last year, the actual rainfall in the month of June was more than the normal value. You know how normal value is worked out. Okay, here this taluka normal rainfall value is worked out for June month. We have seen that the normal value is worked out for a year. Similarly, this value can be worked out for a day, it can be worked out for a month, it can be worked out for a season or for a year. So likewise, we can say that whether this year the rainfall is less or more than the normal value. Okay, similarly for month of June and from June onwards, that is including June and July up to 21st of July, how much total rainfall is there and whether it is less or more than the normal. So that is shown in this table. So if we see from June onwards, normal rainfall value is 235.3, whereas the actual rainfall is 212.3. So there is a less rainfall than the normal rainfall value. So you just browse this website and just visit the website and see how the rainfall record is available. Okay, so this is one more chart that shows taluka normal rainfall values for month of June, month of July, and total values for various circles. Here we can see there is a Shavwadi circle. Okay, and in Shavwadi circle, these are the rain gauge stations: Bredesgaon, Bambode, Karan Spain, Sarud, Malkapur, Amba. Then in Radhanagari again 6 rain gauge stations are there. Okay, in Gagan Bauda there are 2 stations. One is Gagan Bauda and other is Savan. So in Kolhapur district, the maximum rainfall occurs at Gagan Bauda. Okay, similarly for the Karvir Tahsil, Kagal Tahsil, various circles are given. Okay, now after this, next point we are going to learn is the information of precipitation data. Now, just now we have discussed about intensity of precipitation I. So it is P upon T, where P is the total precipitation and T is time. So if the intensity of rainfall is up to 2.5 mm per hour, then it is considered as a light intensity. And if this value is in between 2.5 to 7.5 mm per hour, then it is said that there is a moderate intensity. And if this value is more than 7.5 mm, then it is called as a heavy intensity. Okay, then the duration is also recorded. Aerial extent is also noted or recorded. Aerial extent is the area covered by the rainfall session. So this area covered may be small or large. Then frequency of rainfall. So frequency of rainfall is a very important data. If frequency of rainfall is known to us, then from that it is possible to predict the maximum probable precipitation value. And that value is generally used for design of storm projects. Okay, so that's why now we will discuss about the frequency analysis of rainfall. So what is frequency? The probability of occurrence of an event expressed as a percentage is known as frequency. What is frequency? The probability of occurrence of an event expressed in percentage is known as frequency. So frequency is equal to 100 probability. And how the probability is worked out? Probability is worked out as 1 upon t, where t is the return period or recurrence interval. So what is recurrence interval or return period? Recurrence interval t is defined as it is interval in years for occurrence of an event of same magnitude, and it is a reciprocal of frequency. Okay, it is a reciprocal of the frequency. Probability is 1 upon t. So it is a reciprocal of frequency. And this t is worked out with the formula n upon m. What is t? It is interval in years for occurrence of an event of same magnitude. And this t is worked out from the formula n upon m, where n is total number of events and m is the order number of events. Suppose we have 10 rainfall events. So value of n is 10. And in that, suppose the highest value of rainfall is, let us say, 100 mm. Then order number for this value is 1 and it is denoted by m. Okay, so that is the meaning of term n and m. N is total number of events, m is the order number. If value of m is 1, in that case that event is the highest event, the event with highest precipitation value. So this is about a recurrence interval. The frequency of rainfall, if we say the frequency of rainfall, then it is the number of time that given magnitude of rainfall may occur in the given period. That is known as frequency of rainfall. Okay, so time is over. So let us stop here. Again, we will meet at 12:45. Again, there is a WRE1 lecture. So please wait, let me download the attendance. Okay, now you can leave.